Okay, so today we're doing three things. The first thing is just vocabulary. It's a bunch of words that you tried to give me on Polygon Day. So on Polygon Day, what were some of the words that I wanted on Polygon Day?
Hexagon.
Hexagon was a thing. What did a hexagon have? 6 sides. Who else did we have on Polygon Day?
Octagon.
Octagon. What did octagons have? Had 8. Another one we had that day. Triangles had 3. Another one we had that day.
Quadrilaterals.
Quadrilateral, and that's the theme of the day. Quadrilaterals have 4. Okay, there's a lot of types of quadrilaterals. We're going to learn 6. Okay, so on that first day, people were trying to yell me these names, and I kept saying, no, that's in a different category. No, it's a bigger category. So a quadrilateral is anything with 4 sides. Then there's some special quadrilaterals. They have 4 sides, but then a special detail about them. So I'm going to do a name, I'm going to do a definition, I'm going to do a drawing, and then in upcoming days you probably feel like there's probably some quizzes coming, and you'd be right. What I'll do tomorrow, I'll draw you a drawing, and then you'll tell me the word of what the thing is. Some of these you're going to know, some of these might be new, I'm not sure. But does anybody know a 4-sided thing has something special about it?
Square.
There is a square. So S-Q-U-A-R-E, square. Tomorrow you'll need to spell square right if I draw you a picture of a square. There is a trapezoid. T-R-A-P-E-Z-O-I-D. Trap-E-zoid. Again, tomorrow I'll draw pictures, you'll spell words.
Rectangle.
There is a rectangle. R-E-C-T-A-N-G-L-E. If you do the word A-N-G-E-L, that's not an angle. That's suitable for Christmas time, I guess. That's the word
Angel.
angel. So it's not a rectangle, it's a rectangle. So A-N-G-L-E. Got another one? There is a parallelogram. Parallelogram is spelled like parallel, P-A-R-A. And then do we double this L or the later L? That L. L-L-E-L. So spell parallel, do an O, and then gram. Parallelogram. There's 2 more. We're hitting it pretty well today with this. The final day we do this quiz, you'll do the name and the definition. So it'll just be like an empty paper, but we'll do 4 versions of this.
A rhombus.
There is a rhombus. It has a silent H. R-H-O-M-B-U-S is a rhombus. And then there's one more.
Diamond.
No, diamond would go either in the square or rhombus family, depending on how it's sort of shaped out. It's another trap word, but this one might be the one, I think this is the one people know the least.
Trap square.
Nope. It's trap, it's another E, and it's got a Z in it as well. It's a trapezium.
Oh, that was far off what I was going to say.
That's good, I'm here, you learned something new.
Trapezoid.
The first 3 definitions I'm going to do, which way do I want to go with this? I'm going to go parallelogram first. Does anybody know what makes a parallelogram be a parallelogram in terms of definition or what it looks like or anything?
Isn't it? It has like 4 sides, but like some of the sides, like the tops, are like longer than the side. They're like both of their sides.
Usually they are. They don't have to be shorter or longer, but usually I'd say that's true.
I think they're like slanted too a little.
Sort of. Do you see a parallelogram in the room at all?
What?
I think he pointed at me. I'm not even sure what to do with that.
Oh, wait, that.
Oh.
Okay. So these are all parallelograms. In a minute, we're going to do some math with those. Like I said, we're doing 3 things today. Thing 1 is just vocabulary. Thing 2 is a little bit of math with this. Thing 3 is more just information. But these are all parallelograms. So the most important word for this is going to be parallel. So if we look to this, the top and bottom are parallel. What else is going on with parallel?
The side.
The right and left side are parallel. So to be a parallelogram, you need two pair of parallel sides. So a picture like that. Okay, if you have two pair of parallel sides, right and left are parallel, top and bottom are parallel, that makes that be a parallelogram. Trapezoid. Can anybody describe to me what a trapezoid looks like?
Like the top is short, and then it has two sides that slant like that, and
Okay.
the bottom is long.
Okay, so you showed me this for the sides. How would the top and bottom look like?
Like the top would be shorter than the bottom.
Okay, like hold up your hands like how they'd go though.
Like,
That looks good. Okay, so usually there's the short top, long bottom, but it could be the reverse. Those are just gonna be differently length. And then the sides just kind of do whatever. These might match each other, they might not match each other, that doesn't matter, but yeah, you're gonna have, something like that. But if I turned it sideways, would that still be a trapezoid?
yes.
Yeah, okay, so, anybody, can you think of a way to explain a definition? It's similar to the parallelogram definition, I'll tell you that. Can anybody tell me what's going on with that?
Two pairs of perpendicular lines? Or
No, there's no perpendiculars there.
Looks like the
intersecting.
There's lots of intersecting stuff, but there's something about parallel in this one also.
The top and bottom are parallel and the sides are intersecting.
Okay, so we have one pair of parallel sides. The way that I drew mine, the top and bottom were parallel, so I get one pair of them, and then the other sides just did whatever. So there's a third definition then that's kind of in that same family. If you don't have two pair of parallel sides, if you don't have one pair of parallel sides, and we're trying to look for another sort of combination, what might you have?
4 pair.
I couldn't have 4 pair, because how much is that? 4 pair makes how many items?
8.
8. We don't have 8 sides, we only have 4 sides. So if you don't have 2 pair of them parallel, if you don't have 1 pair of them being parallel, then who's parallel? Couldn't have 3. If you try to draw a shape with 3 parallels and make them connect, that is correct. If you have nothing parallel, if you have 0 parallel sides, that is a trapezium. And that's going to be a shape that up until today, if you saw it, you'd probably say it was nothing. So if I drew you something like this, kind of like an arrowhead kind of thing, that would be an example of a trapezium. Or I could go this way, that way, some other crazy direction, and then come straight down. That's a 4-sided thing. Nobody's parallel to anybody. It's just weirdness. That's a trapezium. Those are the 3 main categories. Okay, so everything has to be a trapezoid or a parallelogram or a trapezium. So let's go to rectangle then. Rectangle, I think you all know, looks like that. If you had a shape sorter when you were a kid, I'm sure it had a rectangle in it. One of those things, it was like a ball, and you put the shapes and it would fit inside the ball. One of those things called a shape sorter. Rectangles are always part of that little kid game thing. But rectangle, there's the drawing for you. Is a rectangle a trapezoid? Because it has 1 pair of parallel sides. Is a rectangle a parallelogram? Because it's got 2 pairs. Or is a rectangle a trapezium because it's just crazy and nobody's parallel? What is a rectangle?
It's a rectangle.
But it's one of these other 3 shapes. A rectangle is either a trapezoid, parallelogram, or a trapezium. It is a parallelogram. So when we do the definition, a rectangle goes in the parallelogram family with what makes a rectangle different than a parallelogram. This shape is different than that shape.
It's straight instead of slanted.
That's true. Let's just look for a mathy word that can do that for us. He's it's like this instead of slanty. What's a word for that?
It's not fancy.
Perpendicular.
Perpendicular. Perpendicular means we're forming a, what's it called?
A right degree angle.
A right angle. How many right angles are in that? 4. Okay, so a rectangle is a parallelogram that has 4 right angles. So is a rectangle a parallelogram?
Yes.
Yes. Is a parallelogram a rectangle?
No.
No. Okay, here's a similar thing maybe in life to that. If you're in Cheswick, are you in Pennsylvania?
Yes.
Here.
Yes. If you're in Pennsylvania, are you in Cheswick?
Yes.
No. Because if you're in Pennsylvania, you don't have to be in Cheswick. Where could you be?
Home. Outside.
Place other than Cheswick.
New Kensington.
New Kensington.
Mills.
Yeah, the Pittsburgh Mills. Although that has probably a Cheswick address maybe.
Pittsburgh.
Kensington.
You know, Plum, you know, city of Pittsburgh, lots of places. But every rectangle is a parallelogram. Not every parallelogram is a rectangle. Let's go rhombus. Anybody know what a rhombus looks like?
I believe it's like something kind of like this, where it's like there and this, but they're both like on the bottom and top, like this on the bottom and top.
That's a pretty good hand thing you had going there. Let's start with this. Is it a trapezoid?
No.
No.
Is it a parallelogram?
No.
Is it a trapezium?
Yes.
No, it's not a trapezium.
It is parallelogram.
It is a parallelogram. A rhombus is another parallelogram with something special about it. If I wanted to let me turn this parallelogram into a rhombus because it's probably my closest one. What could I do to this parallelogram to turn it into a rhombus?
You have to make it shorter.
Which way?
Long.
Yeah, like the long way. So I'd want to do something maybe about like that-ish. That might not be perfect, but that's pretty close in the world of rhombus. Draw an arrow like that. What did he just have me do to that? What did I do? Yeah, so what's true about this now, or close to it? It's not perfect, but it's close.
It's a less wide parallelogram.
Yeah, that's true, but there's something specifically that I tried to do that it's not perfect, but it's pretty close to having been done. What did I do to this?
The up and down sides aren't slanted.
Like these are parallel, but there's something true about all those sides really, comparatively to each other.
They're the same
They're all the
length.
same length. This is about the same length as that, which is pretty much a match for that. Not perfect, but pretty close. And that. If you have a parallelogram and you get 4 equal sides, that is a rhombus. Square's probably the one you know the best. So there I go with a square. What is a square? What clubs does that go into?
Parallelogram.
A square is a parallelogram because it does have those parallel sides, the 2 pairs. That's true. What else is a square?
Rectangle.
A square is a rectangle because it has all those right angles. What else is a square?
A rhombus.
It's a rhombus because it has all those equal sides. So when you write this definition, you could write it 3 ways. You could either say that it is a rhombus with, what does this have that this doesn't have to? This has to have something, and this it's like, if it does, it does, if it doesn't, it doesn't, we don't care.
Straight lines.
Yeah, what was our word for that? Like
Right angles.
Right angles. Okay, so if we have a rhombus and it has 4 right angles, that's one way you could explain a square. You could also say it's a rectangle with something special about it. So what does a square have going on for sure that a rectangle is like maybe, maybe not, we don't care.
Top and bottom are the same size as the left and right.
Yeah, it has how many equal sides?
4.
4 equal sides. You could say it that way. You could also say it's a parallelogram, but then you'd have to say both of those things, and that's a longer definition, so you probably don't want to say it that way. But you could say it's a parallelogram that has 4 right angles and 4 equal sides. That's kind of like up to you how you want to do the definitions. But there's 4 days worth of quizzes. Tomorrow, I'll draw the picture, you spell the word. That's probably the easiest way. The second day, I'll do the definition. You'll spell the word. That's probably a little bit of a harder way to do it. The third way, I'll say the word, you'll say the definition. That's going to be probably the hardest way to do that, other than the final day where I just say nothing and you do the word and the definition, you just fill it on a piece of paper. I'm never going to have you draw drawings for me and me grade drawings. I learned a long time ago I don't want to try to grade 7th grade drawings. I'm just not feeling it. So you'll never draw the drawings for points, but what you will need to do, spell the words right the next 2 days. 1 day from my drawing, 2nd day from my definition, you spell the words. 3 days away, I'll do the word, you do the definition. 4 days away, just empty stuff. Question about where that's going to go? So jot those down or take a picture of that or find them in the book or something. They're around, but you need something to study from on that.
I think.
Second thing we're going to do today is to do something with these shapes, math-wise. So there's a math process, 2 math processes I can ask you to do with shapes. What's one thing we've done before with shapes? I draw a shape, book draws a shape, we say find the
Find the perimeter or the area.
perimeter or area is true. What we're going to do today is the area of, what were these shapes again? What kind of quadrilaterals are they?
Rhombus.
That one was a rhombus, but they're all parallelograms. What we're going to want to do here is multiply a base times a height. Okay, how you're going to know these numbers are going to have to be perpendicular to each other. So there's going to have to be in the drawing some stuff that's perpendicular. So if I say to you that this is 7 and this is 6, are those sides perpendicular to each other? No, they are not. They're not making a right angle. So what they're going to have to do is improve their drawing when they draw it before it's given to you. The teacher, the author of the book, somebody is going to have to draw in a perpendicular segment like this. If I draw that in and I show you my little perpendicular corner and I put a number on that, you're always going to multiply the dotted thing that's been added to the picture times whichever one it made the right angle with. So who did 5 touch in a perpendicular right angle way?
The bottom.
So 5 times 6. This one we go 5 times 6, answer will be
30.
30. Okay, I could also draw my dotted thing like there. So perpendicular world, let me say this is a 5, this could be a 10, I'll make this a 4. We're 100% going to use the 4. Always use the dotted thing. 100% every time use the dotted line. So 100% we're using 4. Then the question becomes, is 4 making a right angle with 5 or with 10?
5. Neither. 10.
Answer is 10. Because this is making a right angle with the bottom, top, right, or left? The top. I don't label the top. I don't need to label the top. Why don't I need to label the top?
Is it the top and the bottom or the same?
Top and the bottom are the same. So this 10 has a friendly 10 up there. This 5 has a friendly 5 over there. But the 4 is making a right angle with the 10. We need to go 4 times 10 and get 40. By perpendicular, I mean it's going to make like a T, or it's going to make an L, and make a perfect 90-degree angle there. They could also go weird and decide to draw the dotted thing outside the shape. So like I could draw it straight down there. I could like extend this side a little baby bit, make myself a perpendicular sign out there. That's still legal. Let me go 3 and 7 and 2. So 100%, which of those numbers we don't even have to think about, we're using it. 2. We're always going to use the
2.
the one that's dotted line. So we've got to use the 2. Then it's a question of, who does 2 make a right angle with? The 3 or the 7?
7.
It's the 7. we've got the right angle symbol going on here with the bottom. I didn't label the bottom, but the bottom's 7 because the top's 7. We're going 2 times 7, so therefore 14. So moral of the story, always use the dotted thing, and whoever it's perpendicular to, multiply them, you'll be good. Question about the root idea of that before I add a detailed question. If I decide to pop meters on these, memories of what you do about the meters when I do that to you. If I throw meters on the picture, anybody remember?
You just gotta add meters to the answer.
That gets us part way. Yeah, we can go meters, but it's not for area, just basic meters.
Meters squared.
It is meters squared, which we could do with the little 2. If I decide to go centimeters, 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 everybody's got centimeters. The answer doesn't just have basic centimeters. What's another way we can write that it's square centimeters? Remember?
You put the square
Yeah, what do we write for square?
SQ.
SQ. We could sneak either a little SQ in the middle or put a little 2 after it. If I just do plain old numbers, then you just do plain old numbers. You don't have to do stuff with those SQs and 2s and stuff, only unless I'm doing the unit. Question about that? Okay, then here's a third thing. This is just information. Are you able to turn me a little bit there, front row friend?
Okay.
This is just information that I told you was coming another day. I told you a few days back that the x for multiplication was about to go out. Anybody remember why the x for multiplication was about to go out?
Because when you do variables, they can use x.
That's
and
correct.
That might be like a times x, but somebody thinks it's a secret number.
That's correct. So if we do this, it's kind of like, is this an x? Is this a multiply symbol? Is it a variable? What is this thing meaning? So there's a bunch of ways that you can show multiplication other than using the x. Does anybody know what those are already?
One of them is you just don't put anything, you put the numbers right next to each other.
That's a sometimes trick. We can't do that for this. We can't on this one just drop the symbol, because if we do, it would look like 53. So what's the sometimes on that? Just, hey, just write it, move. What lets you do that legally?
M. Oh wait, that would think,
When you have like a Z and a two.
Yeah, if there's any kind of a letter, in there. So if I have 5 times 3, I can't just put 53. But if I have 5 times n, I can just write 5 next to n. Or if I have a times b, I can just write a next to b. Those are good solutions there. That would be perfectly good choices. Does anybody know another perfectly good choice? Other than with variables, you can just write stuff next to each other. Anybody know another way to show multiply?
For like the numbers, you put like a little dot in it.
Yeah, there's a thing called a raised dot. It's a decimal point, but like at waist level. If the numbers had waists and were belts, throw a number right about where the belt would go. So we could do a raised dot in between those, or do a raised dot there, do a raised dot there, using what's called a raised dot. That's fine. That is a choice. No, the other choice?
you could put of.
The word of sometimes works. That isn't something we're going to do, but that's a good idea. And the other choice is parentheses. I can do parentheses just around the 5 with no other symbols. Or I can do parentheses just around the 3 with no other symbols. Or if I want to do a little more writing, I can put parentheses around both with no other symbols. If you see parentheses with no other symbols, that's going to mean, starting today, that's a multiply problem. So this. That's 5 different ways that we could write that all mean 5 times 3, we want to get 15. So if I want to write another way here, I could do parentheses around 5, or
Yes.
and, or both. One more go around to that, parentheses around
A,
or,
B,
or.
both.
So next time we take a quiz, which will be tomorrow, doing stuff from this week, there's a question at the end that'll say, like, write these multiplies some different ways. Use some dots, use some parentheses, use some next to writing for the variables, you know, use those tricks. But that's all ways you can show multiplication. So that's just information. This is like a process the homework's gonna ask you to do to multiply. That very beginning is just stuff for us to memorize. So here's where we're going. We're gonna hit up 3 different pages of letters just because there's 3 different things going on. So there's a 183, we're gonna go A to F. The 183 A to F is basically just gonna test your knowledge of the words from the day and then study those a little bit. 185, there's an A to C. What that's gonna have you do is some area problems, just multiplying the correct 2 numbers there. And then 188, we're gonna do A to H, just practicing this. Hey, I can multiply by having it look a bunch of different ways. They all mean multiply. And we'll just call it quits with that. 3 groups of letters. We'll skip a 1 to 25 for a day because we're on 3 different pages.